$2.2 million. That's what Oracle cost a typical 4-CPU enterprise database over 5 years. PostgreSQL? Same workload. $1.38 million. You save $823,000. 37%. I am Dr. Ibrar Ahmed. Today I'm giving you the only Oracle to PostgreSQL migration guide you will ever need. 57 slides. Every tool, every conversion, every error, every fix. If you're DBA, developer, engineering lead, or CTO, bookmark this. You'll come back to it. Look at this chart. License, 190,000. Support over 5 years, another 209. Partitioning option, 23,000 per CPU. RAC, another 23. Advanced security, 15. Diagnostics pack, 7.5. Add hardware and 2 DBAs. 5-year total, 2.2 million. PostgreSQL, right side. License, 0. Partitioning, built-in. Row-level security, built-in. pg_stat_ statements, built-in. 1.5 DBAs because it's simpler. Total, 1.38 million. The kicker, Oracle support fees rise every year. The gap widens the longer you wait. These are real. 2.5 terabytes. Financial services saved 1.2 million per year. 500 gigabytes. Healthcare, 200 PL/SQL packages migrated. 800 gigabytes. E-commerce, near zero downtime via AWS DMS. Who is this video for? Oracle DBAs planning a migration. Developers converting PL/SQL. Engineering leads building the business case. CTOs who want the risk and cost picture. Stay with me. The next slide is the roadmap. Every successful migration walks the same 7 steps. Assess, score complexity with Aura 2PG show_report. Convert, DDL, and PL/SQL, 80% automated. Migrate, bulk load data, choose offline or online. Validate, row counts, checksums, regression tests. Tune, analyze shared_buffers, work anything. Cut over, rehearse twice, rollback ready. Operate, backups, monitoring, auto vacuum. The persistent marker at the top of every slide tells you which phase that slide belongs to. Use it to navigate. Let's go. Chapter 2, Architecture and Data Types, 130 to 430, slides 5 to 10. Architectures map closely. Oracle has SGA, buffer cache, shared pool, redo log buffer. PostgreSQL has shared_buffers in the WEL writer. Oracle uses undo segments for rollback. PostgreSQL uses MVCC, old row versions live in the table until vacuum removes them. Oracle has redo logs. PostgreSQL has write-ahead log. The concepts are the same. The implementations differ. Understanding the difference is how you tune PostgreSQL correctly. Every Oracle type, every PostgreSQL equivalent. Number without precision becomes numeric. Number 10 becomes big int. Varchar 2 becomes varchar. CLOB becomes text, and you don't need dbm anymore. Just select the column. Blob becomes bytea. The one that ruins migrations is date. Oracle date includes time. PostgreSQL date does not. Always map Oracle date to timestamp, never to date. I see this mistake every single time. Large objects. Oracle CLOB maps to text, up to 1 gigabyte. No dbm_lob. Re-needed. Oracle blob maps to bytea for inline binary. For files bigger than 100 megabytes, use the PostgreSQL large object subsystem with low_import and low_export. Oracle file, that external file reference, maps to the large object OID type. If you use AWS DMS, choose limited LOB mode for files under 32 KB, full LOB mode for anything bigger. Oracle create type AS object maps to PostgreSQL create type AS composite types. Table of maps to arrays. Vary maps to arrays with a size check constraint. 4 deeply nested structures. Skip the object relational model. Use JOMB instead. JOMB gives you GIN indexes, path queries, and far more flexibility than Oracle objects ever offered. Most Oracle databases run W8 MSWIN 1252, Windows 1252, single byte. PostgreSQL should always be UTF-8. The problem, invalid byte sequences. Characters that were valid in Windows 1252 are not always valid UTF-8. Aura 2PG handles conversion if you set NLS_lang and client_encoding correctly. For raw files, use iconv. After migration, scan name, address, and description fields for garbled characters before going live. Print this slide. Sysdate becomes current_timestamp or now. NVL becomes coalesce. Decode becomes case. Roundum becomes limit or the row_number window function. The plus sign outer join becomes standard left join. Subster is the same name and one based in both. to_date and to_char work in PostgreSQL with slightly different format strings. Tape this to your monitor. Chop der SQL conversion. Need. Har means kilens. Har means slades disened huson harum. Schema conversion. Table space clauses, PC to far E, initrans, all go away in PostgreSQL. Varchar2 becomes varchar. Number becomes numeric or integer, depending on precision. Oracle 12c identity columns map directly to PostgreSQL generated always AS identity, same syntax. Aura 2PG handles 95% of schema conversion automatically. Sequences map directly. Oracle sequence. Nextval becomes nextval of sequence_name. Curval maps to curval. The critical step is resetting sequence values after data migration, so they're higher than max ID. Miss that, and your first insert gets a duplicate key error. The companion pack has an auto-generator script for every sequence in your database. This catches every Oracle developer. In Oracle, DDL auto-commits. Create table commits everything before it. In PostgreSQL, DDL is transactional. You can create table inside to begin block and roll back the entire thing. That's actually better, but if your code relies on the Oracle behavior, you have a bug. Also, only PostgreSQL procedures manage transactions. Functions cannot commit or roll back. Here it is. The Oracle feature PostgreSQL does not have. Packages. 0. So how do you convert them? Create a schema with the same name as the package. Put all functions and procedures inside that schema. Package variables become a config table or session variables. Package initialization moves into a separate init function. This is the most manual part of any migration. Aura 2PG will split the package, but you must review every function. Cursors work almost identically in PL/pgSQL. Exception handling maps cleanly when an found, when others all exist. The tricky one is autonomous transactions. Oracle's pragma autonomous_transaction lets a procedure commit independently. PostgreSQL does not have this. Workaround, debugging connecting back to itself. Looks hacky, works fine. Or in PostgreSQL 16, use the pg_background extension. Oracle's batch processing. Bulk collect and for will become array_ag in a single update with where ID equals any of an array. Connect by Oracle's hierarchical query becomes with recursive. The recursive CTE is more powerful and standard SQL. Same tree traversal, cleaner syntax. Oracle execute immediate becomes PostgreSQL execute with $sign positional parameters. The big improvement, format, with %i for safe identifier quoting that prevents SQL injection when you build table names dynamically. Sys_if cursor becomes return setoff, cleaner. Just select star from function_name and you get a result set. Triggers split into two parts in PostgreSQL. A trigger function that returns trigger and a create trigger statement that attaches it. The function must return new for before insert or update, return null, and the operation silently cancels. That catches everyone. Also, new and OLD without the colon prefix. Inter-process messaging. Oracle DBMS_pipe is point-to-point. DBMS_alert is broadcast. PostgreSQL replaces both with listen and notify. Simpler, more powerful. Listen subscribes to a channel. Notify sends a message to every listener. Combine it with a trigger and your application gets real-time notifications whenever data changes. No polling. Works in every PostgreSQL driver. Regular views convert directly. Materialized views also exist in PostgreSQL, similar syntax. The difference is refresh. Oracle has on commit refresh. PostgreSQL doesn't. Use pg_cron or your application to schedule refresh materialized view. Use concurrently to refresh without locking readers. Requires a unique index. Oracle procedures don't return values. Functions do. PostgreSQL before version 11 had only functions. Procedures arrived in 11, and only procedures can commit and roll back. Functions cannot. Out parameters work in both, but the cleaner PostgreSQL pattern is returns table or returns setoff, much easier to consume from application code. Oracle DBMS packages. DBMS_output becomes raise notice. DBMS_scheduler becomes pg_cron. DBMS_crypto becomes crypto. DBMS_hub operations become regular text and bytea. No API needed. DBMS_stats becomes analyze. UTL_file becomes copy or pg_file. The ORIFS extension provides compatibility wrappers for the most used DBMS_ packages. Every Oracle exception code maps to a PostgreSQL SQL state. ORA 00001 dup_index becomes unique violation SQL state 23505. ORA 01403 and O_found becomes no_found. ORA 08177 serialization failure becomes 40001. Always catch by SQL state in PL/pgSQL, not by class name. It's cross-version safe. Chapter 4 Migration Tools, 930 to 1330, slides 24 to 33. Or 2PG, the single most important open-source migration tool. Install via Perl CPAN or apartment. The configuration file is everything. Oracle_DSN points at your Oracle source. Schema names which schema to export. Type controls what you export, table, view, function, procedure, trigger, sequence, data. Set PLSQL_pgSQL to 1 for automatic PL/SQL conversion. PG_schema names the target schema in PostgreSQL. Multi-step process. First, and this is the most important command in the entire video, run ORA2PG with type show_report and the estimate cost flag. You get a complexity score, A, B, or C. A is 2 to 3 weeks of work. C is 6 months plus. Then export schema objects one type at a time. Review the SQL files before you apply them. For data, use jobs for parallel export. Test on a subset first. 11 errors I see in every ORA2PG run. TNS could not resolve. Your Oracle_DSN is wrong. DBD. Oracle not installed. Fix Perl driver and Oracle_home. Invalid byte sequence. Encoding mismatch. Set NLS_lang. Relation does not exist. Case sensitivity. Oracle is upper. PG is lower. Value too long. Oracle varchar 2 use is byte semantics. Multi-byte UTF-8 needs more space. You'll hit at least half of these. What ORA2PG actually produces. Left, an Oracle function using number, varchar2, decode, NVL, systate, DBM_output. Right, the automatic conversion. Number becomes numeric. Varchar2 becomes varchar. Decode becomes case. NVL becomes coalesce. Systate becomes current_timestamp. DBM_output. Put_line becomes raise notice. ORA2PG did all of this automatically. The conversion is 80 to 90% accurate. You review and fix the edge cases. PG loader, pure data loader, very fast. Uses the PostgreSQL copy protocol. Supports Oracle as a source directly. For simple migrations, a one-liner connects Oracle and PostgreSQL and copies the data. For production, write a control file with schema mapping, typecast overrides, and parallel worker count. PG loader is faster than ORA2PG for data, but does not convert PL/SQL. Use both. ORA2PG for schema and code, PG loader for data. AWS schema conversion tool and database migration service. SCT analyzes Oracle, converts to PostgreSQL DDL, and generates an assessment report with conversion complexity. DMS handles the data, full load plus change data capture for near zero downtime. The catch, DMS does not convert PL/SQL. Combine DMS for data with ORA2PG or SCT for code. Enterprise DB Migration Toolkit. Commercial. Best when your target is EDB Postgres Advanced Server. Advanced Server has built-in Oracle compatibility. Create package, DBMS_output, DBMS_pipe work natively. Reduces conversion effort significantly. The trade-off, you're tied to EDB's distribution. Hybrid weapon. The Oracle_FDW extension lets PostgreSQL query Oracle tables live. Install it. Create a foreign server pointing at Oracle. Map a user. Then import foreign schema. Every Oracle table becomes a foreign table in PostgreSQL. Select queries get pushed back to Oracle. Join local PostgreSQL tables with live Oracle tables. The Strangler-Fig pattern, migrate one table at a time, and your application keeps working the entire time. 3 strategies. Offline is simplest, stop Oracle, export, import, switch. Downtime equals data size. Online uses CDC to replicate changes in real time. Near zero downtime, more complexity. Hybrid is most common for large databases, bulk load offline, then switch to CDC for the cutover window. CDC tools. On AWS, use DMS. If you already own Golden Gate, use it. Open source and self-hosted, use Debugging with Kafka. Commercial GUI with support contract, Strime, or click replicate. Required on Oracle, supplemental log data, force logging, Golden Gate replication enabled. Cutover pattern, bulk load, replay changes until lag drops below 1 second. Freeze Oracle, final catch-up, flip the application. Chapter 5, Application Code and Query, 1330 to 1430, slides 34 to 36. Connection strings switch from Oracle Thin driver to PostgreSQL, JDBC, or your language's PG driver. Bind variables. Oracle uses $name. PostgreSQL uses $positional. Empty string handling is the silent killer. Oracle treats empty string as null. PostgreSQL does not. Everywhere clause comparing to empty string needs review. ORMs ease this, native SQL doesn't. PostgreSQL has no native hint syntax, but PG_hint_plan adds Oracle-compatible hints. Full becomes seek_scan, index becomes index_scan, use_hash becomes hash join, parallel works the same. Set max_parallel_workers_gather in PostgreSQL VONF to enable parallel scans, hash joins, and aggregations. Force disable a scan type with set enable_sexscan equals off, but reset after the query. DBMS_scheduler maps to the PG_cron extension. Cron.schedule takes a job name, cron expression, and a SQL command. Nightly statistics, 02*** plus analyze verbose. For complex job chains, use PG_timetable from Cybertech, sequential tasks, error handling, conditional execution, remote connections. Chapter 6, Ops and Tuning, 1430 to 1730, slides 37 to 44. Tuning. Run analyze on every table. Set shared_ buffers to 25% of RAM. Set effective_cache_ size to 75%. Work_mem at 256 megabytes to start. Enable pg-stat-basso statements non negotiable. The most common post-migration issue is missing indexes. Oracle plans use different access paths. Run explain analyze on your top 20 queries and compare. Oracle interval partitioning, auto-create new partitions, does not exist natively in PostgreSQL. Use pg_partment with create_parent to pre-create and auto-manage them. Reference partitioning, also missing workaround. Add the partition key to the child and partition both by the same key. Composite partitioning works via nested partition by. And remember, PostgreSQL partitioning is free. Oracle charges $23,000 per CPU. B-tree is identical. Oracle bitmap indexes have no direct equivalent, but PostgreSQL auto-converts to bitmap scans when combining multiple B-trees. Function-based indexes map to expression indexes. Oracle text becomes GIN-ONTS vector for full-text search. Spatial becomes GIST with PostGIS. And PostgreSQL has indexes Oracle does not, partial indexes, BRIN for huge append-only tables, GIN on JOMB. These are game changers. Auto vacuum is the #1 footgun in PostgreSQL operations. Default scale_factor is 20%, too lazy for hot tables. Set it to 2% per table. Monitor PG_user_tables for dead tuples. Use PG_repack for online bloat removal, no access exclusive lock. And never disable auto vacuum globally. Transaction ID wraparound will make your database read-only. Oracle Virtual Private Database maps to PostgreSQL row-level security, actually more flexible. Oracle Transparent Data Encryption maps to crypto for column-level encryption or file system-level encryption for everything. Oracle Fine-Grained Auditing maps to PG Audit. Oracle roles and privileges translate directly. PostgreSQL security is mature and in some areas more granular. Oracle RAC is active-active multi-node. PostgreSQL has no direct equivalent, but Patroni with streaming replication gives you automatic failover with near-zero data loss. Patroni manages leader election via ECT or Zookeeper, pgBouncer or HA proxy route connections. For red scaling, synchronous or asynchronous replicas. C2s extends PostgreSQL for distributed workloads. The HA story is solid and production-proven. Arman equivalent, pgBackRest. Enable wall_level equals replica. Set archive_command to push WEL via pgBackRest. Define a stanza, take a full backup, then incrementals nightly. To restore to a point in time, run backrest restore with type time and your target timestamp. The discipline I demand. Monthly restore drills to a sandbox. A backup you have not restored is not a backup. Install pg_set_ statements. Essential. Query level statistics. Total time, calls, rows, buffer usage. Run Watch2 or Prometheus with Postgres_exporter for time series. Grafana for dashboards. Monitor replication lag, connection count, transaction wraparound, table bloat, and dead tuple count. Alert at 10 seconds of lag, 80% of max connections, or transaction ID approaching wraparound. Chapter 7 Cutover and the Viral Errors, 1730 to 2100 hours, slides 45 to 50. Validation is non-negotiable. 3 columns of SQL on this slide. Run everyone. Column 1, row counts, checksums per column, null count parity, aggregate sanity. Column 2, sequence reset autoscript, char set and encoding scan, time zone verification, constraint validation, LOB byte length parity. Column 3, capture top 50 query baseline with pg_set_ statements. Run bench load tests and verify the rollback path. Switch DNS back to Oracle. Confirm consistency. Measure time to rollback under 15 minutes. Cutover. Define the maintenance window. Freeze schema. Changes 2 weeks before. Run a dress rehearsal on staging. Time every step. On cutover day, stop the application. Run final CDC sync. Verify integrity. Switch DNS. Start against PostgreSQL. Smoke tests. Monitor. Rollback plan ready before you start. Communication plan for stakeholders is critical. This is the cutover playbook. Date T-6, Monday, schema freeze. T-5, Tuesday, full dress rehearsal on staging. T-4, Wednesday, and this is the day people skip. Rollback drill. Practice flipping back to Oracle. Time it. Must complete under 15 minutes. T-3, validation rerun, must be green twice. T-2, Friday, go/no-go review. T-1, Saturday, final backup. T0, Sunday, geo live. Post-migration. Reset every sequence. Run analyze verbose on the entire database. Verify foreign key constraints are valid. Check that triggers fire correctly. Monitor pg_set_ activity for long-running queries. Set up pgBackRest. Configure pg_stat_statements. Document every change. This checklist saves you from the most common surprises. 20 years of war stories distilled into 10 silent killers. 1. Oracle date has time. PostgreSQL date does not. 2. Empty string is null in Oracle, not in PostgreSQL. 3. Case folding flips, Oracle upper, PG lower. 4. Autonomous transactions don't exist. 5. No packages. 6. Forgot analyze equals terrible plans. 7. Sequences still start at 1. 8. No connection pooler equals death at 200 connections. 9. Default auto vacuum is too lazy. 10. Default pg_f is open. Read each twice. Test for each. Traps 1, 2, and 3 together cause 80% of post-migration application bugs. The exact errors your application will throw on day 1. Column employee_ID does not exist. Lowercase your SQL. Operator does not exist. Character varying equals integer. Add explicit casts. Function NVL does not exist. Replace with coalesce. Syntax error at colon change to $positional. Relation dual does not exist. Remove from dual. Duplicate key, sequence not reset. Slow queries, missing analyze. Too many connections. Install pgBouncer. Date out of range. Date should have been timestamp. Pin this. You'll hit at least 8 on day 1. Chapter 8, Business, Team, Resources, 21 to 2230, slides 51 to 56. A realistic 30-day plan for a medium complexity database, 500 gigabytes, 50 packages, 4 to 6 engineers. Week 1, assessment, environment schema. Week 2, PL/SQL conversion, the heaviest phase, 40% of effort. Week 3, data load, app changes, testing. Week 4, staging rehearsal, cut over, stabilize. Bigger databases or more PL/SQL extend the timeline proportionally. A migration lead who knows both Oracle and PostgreSQL. 1 or 2 PostgreSQL DBAs. 2 to 4 PL/SQL developers, the largest effort. 1 or 2 application developers. 1 QA engineer. For under 100 gigabytes with minimal PL/SQL, 3 people, 2 to 3 months. For over 5 terabytes with heavy PL/SQL, 12 plus people, 12 to 24 months. 3 real migrations. Financial services, 2.5 terabytes, 14 months, 60% cost reduction. E-commerce, 500 gigabytes, 8 months, 3 times faster catalog queries with JOMB and GIN, 2 million per year saved. Healthcare, 5 terabytes, 18 months, HIPAA passed, for million per year saved. Common thread. Every team overinvested in validation and cut over rehearsal. None of them got burned on Go Live. The front-end stack. Oracle Apex is hardest to replace, tightly coupled to Oracle. Alternatives, ToolJet, AppSmith Retool. Oracle Forms, replace with React or Next.js plus Postgres, which auto-generates a REST API from your PostgreSQL schema. Azure gives you instant GraphQL. Oracle Reports, Jasper Reports for pixel-perfect PDF, or Apache Superset and Metabase for interactive dashboards. Bookmark these. Or a 2PG on GitHub, your primary tool. AWS SCT and DMS, cloud migrations. PG Loader, fast data loading. The PostgreSQL documentation, the best database documentation in existence. The ORIFS extension. PCrypto, PG_cron. PG Audit. Join the PostgreSQL Slack and the pgSQL general mailing list. Incredibly helpful and fast to respond. Screenshot this slide. Top 10 data types. Top 14 SQL function replacements. PL/SQL syntax map. Top 8 error code mappings. The tool decision tree. And the risk-scored summary of every Oracle feature. This is the one slide your team will reference every day for the next 6 months. Chapter 9, close, 22:30, end, slide 57. That's the playbook. 57 slides. Every tool, every conversion, every error, every fix. Now, 3 things, each takes 5 seconds. 1. Subscribe at youtube.com/@drIbrahmed. 2. Press the bell. Pick all notifications. I drop a new PostgreSQL deep dive every week. 3. Comment the word migration below, and I'll DM you the full GitHub companion pack, or a 2PG config, validation SQL, cutover runbook, top 20 error fixes, and the TCO calculator. Share this with your DBA team before you start a real migration. I am Dr. Ibrar Ahmed. See you in the next deep dive. Allah Hafiz.